explained what protons, electrons, and neutrons were. And we went through the atomic structure of how each element was arranged. And remember that I told you that we were going to do a quiz. So first I'm going to introduce you to what we're going to be doing today. So it would be our content. So today's lesson, we are basically doing classification of matter by its composition. So for example, matter is made up of mixtures and pure substances. And I will explain what these are later on. So in a mixture, you have a heterogeneous mixture and a homogeneous mixture. And then in a heterogeneous mixture, we have suspensions. Now, suspensions means that the particles that are in the substances, it does not dissolve. Now, in a homogeneous mixture, we have solutions. Now, solutions means like when we put sugar in water and we stir it, then the sugar dissolves in the water. Now, when we go to pure substances, we have compounds and we have elements. Now, remember I told you elements were made up of atoms, and some elements are also made up of molecules. Now, I'll explain later on what molecules are to you. Now, pure substances are also made up of compounds. Now, compounds can be separated. So now this is basically what we're going to be doing in our lesson for today. So I'm going to start with the quiz, which is the periodical table. Then I'm going to discuss classification of matter, pure substances, elements, and molecules, compounds, and also mixtures. Right, so from last week's lesson, I'd like to know who can name the elements. Now, if you look here, I have written the elements of oxygen, hydrogen, and oxygen. So H is the symbol, and hydrogen, I wrote down the element. Now, O is the symbol, and I wrote down oxygen. Now, I'd like you either to type out the answer of the elements that are listed here, or you can verbally say what they are. Who would like to go first? I see two participants have raised their hands, so I'll ask my host if he can unmute you.
Hi. Hello.
Hello, how are you?
Fine, thanks, and you?
I'm good, thanks. We need to name a symbol and then the element.
All right. H, ma'am, no, on the first table.
Okay.
He is helium.
Oh, well done. That's it.
Li is lithium.
Yes.
B is beryllium.
That's correct. That's correct.
B is boron.
That's correct.
C is carbon.
Okay, well done.
N is I forgot N. Yeah, that's all I know.
Nitrogen.
Yes.
Okay, let's give someone else a chance. That's very good. Well done for that. I'm very proud of you for learning it. So can we give someone else a chance? I'll ask my host to unmute you. Hello? Anyone else like to go? No, okay. Yes, I can hear you.
Excuse me.
Hi.
Hi.
Do you want to continue from F?
No.
No, okay. Someone else? Hi.
F is fluoride, N is neon, Na is sodium, G is magnesium.
Okay, and Al?
Aluminium, Si is silicon.
Oh, well done. I see you've been learning. Good for you. Okay, anyone else? We'll start on the second table here with P. Who'd like to go? Nicole? Yes, Nicole. Okay.
P is potassium, phosphorus. S
Yes.
is then S is sulfur. Cl is chlorine. K is for potassium. Ca is for calcium. Ag is for gold. No, silver.
Ag is, yes, correct.
Silver. Au is for gold.
Yes.
Hg is for mercury. Cu is for copper.
Yes.
Co is for carbon.
No, CO is starts with co, and it has
Cobalt.
B. Yes, that's
Cobalt.
correct. Cobalt.
Cobalt. And Br is for bromine.
Yes.
PET is for platinum.
Yes.
Zn and Zn is for zinc. And PB
Yes.
is iron.
Lead. Oh, very well done. I'm very proud of you. So we're going to continue. And for all of you that have learned this, I'm very, very, very proud of you. So we're going to move on to the next slide, where in previous lessons, I had told you that matter is classified into something that takes up space, and it was made up of three phases, that being the solid, the liquid, and a gas. So now we're going to further define what matter is made up into. So it is categorized basically into pure substances here in the table, in this diagram, and into mixtures. Now, pure substances are divided into elements and compounds. Now, elements, as I told you previously, were made up of metals, metalloids, and non-metals. Now, if we had to move on to mixtures, now mixtures are basically homogeneous and heterogeneous. Right, so I will explain what these two terms are later on in the lesson. Please don't be afraid of all these new terms. They're actually quite easy if you come to think about it. I see that somebody has raised their hand. Can I ask my host to unmute you? Okay, so I'm going to continue. So we have basically matter can be broken up into two categories, which is basically the pure substances here and the mixtures here. And then pure substances can also be broken down into elements and into compounds. Now, also to explain further, we have mixtures. Mixtures are physically combined structures that can be separated into their original components. So I will explain that to you later on as we're going along. And chemical substances are composed of one type of atom or molecule. So we're going to move on. So we have, what is a pure substance? So basically, a pure substance is a substance that is made up of only one kind of particle. So a pure substance is made up of only one kind of particle, and it has a fixed or constant structure. Now this means that the structure of this pure substance does not change. It is fixed. Now, pure substances can also be classified into elements like you see in this diagram here, and compounds in the second diagram that has the red little marbles on them. Now, when I said it has a fixed constant structure, if you look at this diagram, what I'm pointing to, these particles in here are fixed. That means it does not move. Okay. So we say an element is a substance that consists of one type of atom, one type or kind of atom, and an element is a pure substance as it cannot be broken down. Now, throughout this tutorial, I'm going to stress the fact that an element is a pure substance and it cannot be broken down or transformed. Transformed means that it can take on another um, uh, uh, a substance or another this thing into it cannot be transformed into a new substance. That means it cannot be broken down into a new substance by any physical or chemical means. So now this element here, you cannot break it down. Okay, so elements are mostly metals, non-metals, and metalloids. So we're going to continue here. So we have compounds on the one hand, on the other hand. Now these are pure substances when two or more elements are combined chemically in a fixed ratio. So if we look at the picture here on the right hand side, you can see that this compound, it is made up of two elements in a fixed ratio. So like you can see, you have the red marble and actually I won't say marble, you have the red molecule and on it element, and then you have the two white element circles on it. Now all of them are in a fixed ratio, and the compound consists of atoms that are of one or more kind. Now different atoms are combined in little clusters, and these clusters are all exactly the same. So if you look at the picture on the right, all the molecules in here are basically all the same in a fixed ratio. Now, important for you to note is that these substances cannot be separated by any chemical method. And I will continuously repeat this as we go along. So now we're going to list the characteristics and the properties of a pure substance. But before I do that, I want to introduce the concept homogeneous to you. Now, homogeneous means a process involving substances in a same phase. Now, this word I will explain to you in a different slide, the exact meaning of it, and you'll be able to understand more about what the term means. So, we say pure substances are mostly homogeneous in nature. So this means that it contains only one type of atom or molecule. So homogeneous in nature means that it contains only one type of atom or molecule. Now these substances mainly have a constant or uniform composition throughout. So we say that it has a constant or uniform pattern. Like in the previous slide that I showed you, it has a fixed pattern. So that's what they mean by it. Now, substances have fixed boiling and melting points. So the boiling point and the melting point is fixed. Like for example, water boils at 100 degrees Celsius. Now, the pure substance usually participates in a chemical reaction to form predictable products. Now, basically, from the periodical table, when you have pure substances and they take part in chemical reactions, we basically know what type of product that it is going to form. So that's why we say it forms a predictable product. Okay, so we'll move on and I'll give you examples of pure substances. Now, all the elements are mostly pure substances. Now, a few of them that are pure substances are basically gold, oxygen, chlorine, and diamonds. Now, we have compounds that are pure substances. These are salt, water. Another name for the salt, you could say, not another name, we have crystals, baking soda. Amongst others, they are also grouped as pure substances. Now, this is because it has a uniform and a definite composition. That means it is chemically identical. So when we say it has a uniform and a definite composition, we mean that it is chemically identical. So is there anyone that would like to ask me a question on these characteristics and properties if you don't fully understand it? I'll give you a chance to do so now. Okay, so then I can continue. So now I'm going to explain what elements are. So basically, an element is a material. Yes, can I ask my host to unmute you, Dale? Hi. Okay, so I will come back to you. I'm going to explain what an element is. An element is a material that consists of atoms of only one kind. So from the previous tutorials that you've learned, we've had, and this tutorial, the most important thing you need to know about an element is that it consists of atoms of only one kind. And examples of these atoms are hydrogen, oxygen, carbon, sodium, and chlorine. So what you noticed as we're going through all these tutorials, that from the beginning, the first one we did, this content is actually becoming easier for you to understand. It's becoming more clearer. And mostly it's because some of the information I have, I've repeated it in different ways to help you understand it. Okay, so all elements that we know so far are listed on the periodical table, and there is only a limited number. And they are the building blocks of millions of compounds. Now, when you say building blocks of millions of compounds, what we mean is that these elements, through chemical reactions or other physical means, when they put together, they make up different types of compounds. Okay, now basically like how bricks are. If you drove past and you saw somebody building a complex or building a house, and you see the bricklayers all working in harmony, where one brick is passed to another person, and they work collaboratively, meaning that if they work together as a team, their work gets done easily, and then they lay the bricks next to each other, and this basically lays a foundation. So we're saying that basically elements and compounds, elements are the building blocks of compounds, right? So in a substance which cannot be broken down in similar substances by, elements are substances which cannot be broken down into similar substances by chemical means. So now we look at this example we have here, helium. So helium is an element, and I'm going to explain more about it in this next slide here. So some elements, they cannot exist by themselves. That means that some elements, like for example, take you for an example, you basically exist within your family. And right now at your age, you basically cannot exist without your family, because you need your mom and dad and your brothers and sisters, even though your brothers and sisters may irritate you at times, but you need them to support you and even sometimes irritate you, because sometimes, it could be fun and it could be nice when they tease you in a good way. So some elements cannot exist by themselves, just like how you cannot exist right now because you are little. You cannot exist by yourself. So elements also, or not all of them, just some of them, they cannot exist by themselves, even when they are isolated from any other type of atom. So elements of this nature will combine with atoms of the same element in order to be stable. So what we mean here is that if you look in the diagram below here, we say that the element, for example, oxygen, it cannot exist by itself. Remember, oxygen in the periodic table would be, when you look at it, the chemical symbol, it's 0 with a small 2 at below it. So this means that it cannot exist by itself. So that means it combines with another atom. Okay, so I'll explain also. In other words, we say hydrogen is diatomic. Diatomic means that it cannot be by itself. It cannot exist as simply hydrogen. Now, hydrogen is so reactive that when it is isolated from everything else, it will still combine with another atom. So the hydrogen makes up two atoms, which was called a molecule. So we use the word diatomic. Okay, so explaining it more. Now, there are 8 elements that form the diatomic molecules that cannot exist by themselves. I see some participants have raised their hands. Can I ask my host to unmute you? And then you can ask me a question. Or you can go on to chat and you can ask me a question. Okay, so I will continue. So there are hydrogen, you have nitrogen, you have oxygen, you have fluorine, you have chlorine, you have bromine, you have iodine and acetylene. Now all these are called molecules of elements. Now what I'd like you to do is I'd actually like you to highlight these elements in your periodical table. So these are diatomic. So it is called, these elements that are diatomic is hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and acetylene. Okay, so they cannot exist by themselves. So this is an example of a diatomic oxygen molecule. Okay, so now I want to explain what molecules are. So basically, molecules are clusters of atoms in the previous example that we used. So molecules are a cluster of atoms. Now, molecule is very important word in chemistry. A molecule is two or more atoms that have chemically bonded with each other. So basically, the definition of a molecule is a molecule is two or more atoms that have chemically bonded with each other. Now, this means that it is a collection of atoms in a definite arrangement. Definite arrangement means that it is fixed, it does not move. Now, the atoms in a molecule can be of the same kind, in which case we would say that it would be a molecule of an element, or they can be of different kinds. Now, if they are different, it would be molecule of a compound. May I ask my host to unmute participants that have raised their hands? As you can, when I hear you, I will address you, but I will continue in the meantime. Okay, so not all elements have molecules. The elements on the left-hand side and the middle part of the periodic table are solids at room temperature. So we say that not all elements have molecules. So now if you look at the periodic table, so what I suggest you do is you can click on one of the earlier slides, that earlier tutorials that I had. You can go to it and click on the slide where you had the periodical table and then print it. So you can use this for learning purposes, and you can highlight stuff, and you can highlight the metals, the non-metals, the metalloids, then you can highlight the ones that are molecules, and now you can also highlight the um, the elements that do not have molecules. So the metals on the left-hand side and the middle part of the periodic table are called solids. So you can label that as well. You could say that this is a solid at room temperature. So they exist in tightly packed arrays of atoms. Now remember, if you add heat to it, then it becomes something else. So we have many of the non-metals on the right-hand side of the periodic table are gases at room temperature, and that exist as molecules made up of two atoms each. So now the gases on the right-hand side of the periodic table are made up of two atoms each, and you call these diatomic molecules. One of the best ways of learning is also through doing mind maps. So if you have your periodic table, then you can use lines, and you can actually take your line and then write diatomic, and then you could write solids and stuff like that. So it will help you actually learn holistically, meaning that it puts everything into perspective for you when you do that. So I wrote here the definition of diatomic for you. Diatomic refers to a molecule made up of two of the same atoms bonded together. So diatomic means that we have a molecule that is made up of the two same atoms, and these are bonded together, like as in oxygen. So remember I told you the symbol for oxygen is 0, O, and it has a small 2. So it has two of the same atoms together. So di means two. And then as you go through the module, not this one, you will learn about triatomic molecules. And this refers to where it is made up of three atoms of the same kind. Like, for example, you have ozone. So you have three atoms that are very similar. They are bonded together to make ozone. So it's the molecules, and the symbol is 0 with a small 3 at the bottom. So now we're going to move on to compounds, and we're going to say now what are compounds. Now sometimes atoms react together chemically to form molecules or compounds. So when these elements or these molecules react together, they basically form compounds, right? So a compound is a material that exists of two or more different elements chemically bonded together, such as water. So you have two hydrogen atoms and one oxygen. Carbon dioxide, so you have one carbon and two oxygen. And we have hydrogen fluoride, which is the symbol HF, and sodium chloride, which is NaCl. The atoms in a given compound are always combined together in a fixed ratio, such as water, where the ratio is two hydrogen atoms and one oxygen atom. So if we're going to look at the picture here, we look at the red marble, which is one element, and then it is attached to two different elements of the same kind to make one compound. Now, a chemical is a force that holds atoms. A chemical bond is a force that holds the atoms together. So if you look at this one at element here, you could see that it is bonded together by chemical means. So you have the two hydrogen atoms sitting on the one oxygen atom. So I'm going to repeat, it is bonded together by chemical means. Now, atoms chemically combine in fixed ratios to form compounds. So atoms are chemically combined in fixed ratios to form compounds. Now, when we say fixed ratios, that means that we have, say, water. You have water as in two hydrogen atoms sitting here and one oxygen atom. So it's in a fixed ratio. So two hydrogen atoms here and one oxygen atom here. Right, you're going to ask yourself, now how do these atoms combine? Okay, so for the oxygen, these were atoms that combined, and for the compound, these, for like in water, these were the elements that combined. So now the question is, how do atoms combine, and what makes them stick together to form molecules? So we're going to go on into our next slide that will explain this to you. So we say that basically these experience an attractive forces. So the compounds experience an attractive force. So that's what helps them to combine together. And the force is slightly more complex than the forces that you get between magnets. But now, between magnets, but they work in the same way. Now, the force holds atoms together as if they were stuck together like glue. So now these forces, they basically hold together in a way like how glue sticks things together. And these forces that hold atoms together are called the chemical bonds. Now, if we look here at this water, it is one oxygen and two hydrogen. So these hydrogen atoms are attracted to this oxygen atom, and it is held together, sorry, excuse me, by a chemical bond. Right. So in the water molecule, the chemical bonds between oxygen and the two hydrogen atoms hold the whole molecule together. So this bond basically holds this molecule together. Now we can ask, how many chemical bonds is there in each water molecule? So if you look at this diagram and how, as I've been explaining, you would see that there is one oxygen atom and two hydrogen atoms, and this is how it forms your molecule together. Okay, so we will continue. Right, the water molecule has two identical OH bonds. OH bonds means that it has two identical oxygen and hydrogen bonds. Now, what would happen if you had enough energy to break those bonds? Now, also, what would we have if we separated water molecules into their atoms? Now, theoretically, what this basically means is that we would have hydrogen atoms and oxygen atoms. What actually happens is that the hydrogen atoms immediately combine to form H2, and the oxygen atoms immediately combine to form oxygen. So I will show it to you in this diagram here. We have water here for an example. Now, if we had to separate these atoms, it is basically what we have here is two hydrogen atoms and we have two oxygen atoms. Okay. When atoms separate with each other and recombine into different combinations of atoms, we say a chemical reaction has occurred. So now, a chemical reaction is when we are separating compounds, right? So now, in the above chemical reaction, the water has decomposed. Now, decomposed means broken up, and it has recombined into smaller molecules. And we say that water has undergone a decomposition reaction. Decomposition reaction basically means that water has broken down into its separate elements, which is hydrogen and oxygen. Now, you need to understand that not all chemical reactions have decomposition reactions. That means not all elements, compounds can be decomposed. So now we say compounds such as water, carbon dioxide, and salts are formed by chemical reactions. Now, compounds can be broken down in a decomposition reaction into other compounds or their original elements by heating or electrolysis. So now basically, I'm going to repeat that so I can explain it to you. compounds can be broken down in a decomposition reaction. Now, this basically means that compounds can be broken down, and it can be broken down by a process called a decomposition reaction. And it is broken down into other compounds or by their original elements, and it is broken down either by heating or electrolysis. Now, for example, electrolysis decomposes water to form hydrogen and oxygen. So if you look at this diagram here on your right, if we introduce what electrolysis to you, electrolysis is the decomposition of an ionic compound by passing electricity through the molten compounds or aqueous solution of compounds. So here in the beaker is water, and they passed electricity. Now electricity is passing electrolysis through this water compound, and basically what happens is that the water separates and it forms hydrogen and oxygen. Okay. So another example of electrolysis is a clearer example here is where you have this picture here. You have a power supply, so that is heating this water, and you see it forms hydrogen. The bubbles coming out goes into hydrogen gas, and the oxygen coming out here. So this water is broken up into hydrogen and into oxygen. So there are two important events that basically happens in a chemical reaction. You have a chemical bond break and a new chemical bond form. So the two important is one, the initial chemical bond, it breaks. Like for example, the chemical bond of water, it in a chemical reaction had broke. And then we have new chemical bonds that form. So we have hydrogen and we have oxygen. Now this means that all reactions, the atoms of the molecules rearrange themselves to form new molecules. Okay, so in the water when we applied electrolysis to it, the water rearranged itself into hydrogen atoms and oxygen atoms. Okay, so the chemical formula of water is H2O, and you can see it has two hydrogen atoms and oxygen atoms and one molecule of water. So now, can you think what the chemical formula of CO2 is? Does anybody know? If you want, what do you think the chemical formula of CO2? Does anyone want to answer? Yes, I'll ask my host to unmute you. CO2, carbon dioxide. What is the chemical formula? Hi. Okay, you can type out your answer in the chat box. You're welcome to do so, and I'll have a look. CO2, yes. What is the chemical formula of? Yes.
Ma'am, I think it's carbon dioxide.
Yes, carbon dioxide, but how do you think that if we heat it, what would it be broken up into? Very good for knowing CO2 is carbon dioxide, though.
Won't it be broken up into gas particles?
Yes, what
gas
are
particles.
the particles? Yes, what would the gas particles be called on its own, the elements? Like say, for example, I had water here, H2O. The water is broken up into hydrogen elements and oxygen elements. So this carbon dioxide is broken up into, if you remember the periodical table, what's the symbol for C? Can you remember?
No, ma'am.
Sorry?
Oh, ma'am.
Yes?
I can't remember, ma'am.
Okay, no problem. So C was carbon and O2 was oxygen. So we're all here to learn, and as we learn from each other, and we all help each other. Because one of the basic philosophies in my life is that to actually help each other, and also we always all learn. Even when we're old, 100 years old, we're still learning. So we have mixtures and elements and compounds. Now, elements are compounds and are found in mixtures together, such as air, seawater, rocks, and in living things. Now, mixtures are separated by chemical means. So I explained that to you, that we use chemical means to separate mixtures. And compounds are separated by chemical sorry, let me redo that. So I was wrong. Mixtures are separated by physical means. That means that you have to physically separate mixtures. So for example, if you had to mix rice and sugar, so this mixture cannot be separated by any sort of chemical means. You have to physically separate the rice and the sugar, which is an extremely difficult task to do because the sugar is very small. Then we have compounds can be separated by chemical means. Now, chemical means is when we apply, like for example, heating or electrolysis. So we separate these compounds. Now, salt, water, uh, sand and water, oxygen and hydrogen and air are examples of compounds. Now, the compounds of a mixture can be present in varying proportions, right? That means that the components of this mixture, they vary in its proportions. That means that it is not fixed. Now you'd ask yourself, what is a mixture? A mixture is a substance made up of mixing other substances together. So basically, for example, the example I should have used is, say, for example, if you used mixing flour and rice. So if you take a sieve and you sift the flour out, you actually be able to separate the flour and the rice, because the rice will remain in the sift and the flour will go into the container. So there's in mixtures separating through physical means, you would have learned in your lower grades the different processes of separating mixtures. Now it consists of different kinds of elements that are combined together physically and not chemically. Okay. Now, you have a homogeneous mixture. Now, impure substances are called homogeneous mixtures. Now, why we say impure substances, impure substances are called mixtures, sorry. And why we say impure means that it is mixed with another substance. It's not pure like an element, right? So mixtures are further divided into homogeneous and heterogeneous mixtures. And now when I use the word impure, I don't mean that it is dirty. I mean impure because it is mixed with another substance. Now, a homogeneous mixture contains two or more chemical substances. When a spoonful of salt dissolves into a beaker of water, we have a homogeneous mixture. So a homogeneous mixture has a uniform composition throughout. That means uniform composition means that it is the same throughout the mixture. And this means that every unit of mixture is like every other unit, and the various components of these mixtures cannot be seen. So if you had to dissolve salt in water or sugar in water, you cannot see the sugar anymore because it has dissolved completely. Okay, so a homogeneous mixture is also called a solution, that you have learned basically in earlier grades. Now, it is constant. The mixture is the same throughout the solution, as I explained earlier when I did the salt and the water. In solutions, we have distinguished between a solute and the solvent. The components that represent the largest amount is the solvent. That means in the case of the salt and water, you can tell me what is the solvent, and the solute is the substance that dissolves the solute. So the solvent would be the water, and the solute would be the salt, because the solute is a substance that dissolves the solvent. Now, if we look at the phases of homogeneous mixtures, we have gas in gas. So the components basically is oxygen in nitrogen, and that makes air. We have liquid in gas, so water vapor in air, that makes moist air. Liquid in gas, so this is carbon dioxide in water, this makes soda water. Liquid in liquid, so we have alcohol in water, which makes wine. Solid in liquid, which is salt and sugar in water, which is brine and sugar water. Liquid in a solid, it is mercury in silver, and it is mercury amalgam. And we have solid in solid, which the components is copper and zinc, which makes up brass. Now, if we use these two examples of mercury and amalgam and brass, now these are both called alloys. Now, an alloy is a mixture of metals, or a mixture of a metal with another element. Now, dental amalgam is a liquid mercury and a metal alloy mercury, and it is used to fill cavities caused by tooth decay. Now we have heterogeneous mixtures, and this is a mixture whose components vary from spot to spot within the sample. For example, if you put a little amount of sugar in a vessel and add some sand and you shake it into the jar, this mixture does not have the same consistency throughout the jar, as the sand is heavier. So what will happen is there's possibly you will find that the sand settles at the bottom, because there will be more sand at the bottom of the jar. And then towards the top part, you would get the sugar, because the sand is heavier. And these mixtures can be identified and separated physically by physical means. If we make sulfur and an iron filling, the sulfur crystals, which is sulfur powder, and the iron fillings remain separate. Now, a heterogeneous mixture does not have a uniform composition. It means that it is not the same throughout. It varies, like when we say the sand is at the bottom and the sugar is at the top. Right, so examples of heterogeneous mixtures, we have suspension. So suspension basically means that when substances do not dissolve, like a solid cement in water, we have a cement slurry. Then we have emulsion. Emulsion is oil in vinegar. That is your salad dressing. The oil state. And then we have gel. We have a liquid trapped in a solid. That would be examples. It would be fruit jelly. We have fog and also aerosol, which is liquid in a gas, which is spray paint. We have smoke, solid in a gas, which is smoke. We have foam. Gas is trapped in a liquid, which is shaving cream. And we have a solid foam, which is gas trapped in a solid, which is polystyrene foam or foam rubber. Okay, so the differences between pure substances and mixtures. A pure substance cannot be broken down or separated into new products. It can be separated using different separation methods. And a pure substance is constant physical and it has constant physical and chemical properties, while mixtures have varying physical and chemical properties. Pure substances consist of a single element, while mixtures come as a combination of two substances or elements. Right, so then we have metals, differences between metals and non-metals. So metals are metallic luster, and non-metal means that it is not shiny. So metals are ceruleanous. These are new words for you. That means it has a ring or ting when you tap it. So non-metals are not ceruleanous. Then metals are malleable, which means that it is hammered into sheets or molded, and non-metals are brittle. And metals are ductile. That means it can be stretched, and non-metals are non-ductile. Then we conduct, metals can conduct heat, and non-metals are usually not good conductors of heat. And then metals, all solids at room temperature, all are solids at room temperature. And in non-metals, it can be solids or gas at room temperature. So metals are good conductors of electricity, and non-metals are usually good electrical insulators. That means that it does not conduct electricity. So now metalloids. Metalloids is a chemical element with properties in between, or that is an example, that is a mixture of a metal and a non-metal. So we have 6 examples of 6 commonly recognized metalloids, which is boron, silicon, germanium, aniseed, antimony, and beryllium. Now, metalloids usually look like metals, but they behave largely like non-metals. They are shiny, brittle solids, and they are relatively good conductors of electricity. Now, what I'd like you to do is I'd like you to fill in the blanks. You can call it out. I've given you a ton. So basically, matter, can it be physically separated? This is basically what we've learned so far. Yes, it can be physically separated, but what can it be physically separated into? What would you say here? Can I ask my host to unmute you? Nanshlanshla, would you like to speak? Hi. Okay. So where my laser is pointing here, we would say it's a solution. Yes. What are the answers? Do you know?
I think it can be separated through 2 metals, ma'am, 2 solids.
Okay. So say we have here mixtures are broken down into, what would I put here? I mean, matter is broken down into a
solid or gas, ma'am.
A mixture and a pure substance. Now, a mixture can be broken up into a solution or a suspension. And then we have pure substances are broken down into elements and compounds. Okay, so what we learned in this lesson is that all matter is made up of tiny particles called atoms. The atoms of each element are unique and essentially identical to each other, and all known elements are listed in the periodical table. So we have subatomic particles. We have 3 main subatomic particles that determine the structure of an atom, which are protons, neutrons, and electrons, which is from my earlier lesson. And protons are positively charged and are found deep into the nucleus and at the center of the atom. So I'm also recapping what I did in my last lesson. And neutrons are similar protons in size and mass, and they do not carry any charge, and they are found in a atom nucleus. So we have electrons are negatively charged particles, and they are much smaller than protons and neutrons, and a cloud of and they basically form a cloud of fast moving electrons around the atomic nucleus. And a neutral atom is a number of protons, which is always equal to the number of electrons. So then we say that the atom is neutral. So in pure substances, we learn today that all matter can be classified as mixtures or pure substances. Pure substances can be further classified as elements or compounds. Elements, all atoms in an element are of the same kind. That means that the atoms cannot be changed into other elements or by any physical or chemical processes. And elements can be built up of individual atoms or bonded pairs of atoms called diatomic molecules. And when elements combine, they form compounds. Right. And we also learned that in a compound, an atom of 2 or more kinds are chemically bonded in a fixed ratio. The atoms that make up a molecule are held together by a special chemical attraction force called a chemical bond. Then compounds can be formed and broken into chemical reactions. A chemical reaction is a compound and it is broken down into similar compounds and even elements. And this is caused by through a decomposition reaction. Compounds cannot be separated by physical processes as they are as they can be separated into the elements, and this is through a chemical process. We have mixtures. Mixtures are a combination of two or more elements or compounds, and the compounds of a mixture can be separated by physical separation methods such as sieving. So information from this tutorial was derived from the natural science workbooks provided by the Department of Education. Daniel de Eck also provided some slides to me, and you can visit bjuskin.com to find out more about substances and mixtures. So our next lesson, I'm going to discuss the change of state, the particle model of matter. I'm going to discuss diffusion and the change of, and in change of state, I'm going to discuss evaporation, condensation, freezing, and melting, and basically how that works. If any of you would like to contact me, if you do not understand anything, or if you'd like clarity, or if you even like the slides, you may do so at ahaffea@gmail.com. And please follow us at Africa Teen Geeks #lockdown eSchool. I have enjoyed sharing this information with you, and I am always willing to help you, so you are welcome to um, email me at any time. I don't mind. Thank you so much for listening and attending, and I wish to see you tomorrow. Bye.